Okay, a few of you mentioned that you could use some more videos on graphing trig situations. All right, so first of all, know that sine looks like an S. All right, and so when I say that, I mean starting at 0, 0, it looks like an S. And what you're really doing is you're just taking these key points around the unit circle and you're like, okay, so, when we're right here, it's what? 1 over and 0. Okay, so if I'm graphing the sine at this point, I'm at 0. If I come up here, I'm at 1. So this is pi over 2, I'm at 1. If I go over here, I'm negative 1. Here my sine is 0. I'm back here, and that's at pi. So this is pi. If I come over here, I'm at 0, negative 1, which is this guy, 3 pi over 2. And then when I get back to 2 pi, my sine is 0 again. So when you're graphing the sines, you're going around the unit circle and you're putting it in a two-dimensional graph, okay? Cosine of theta looks like a cup in that same amount of time. So it goes high, mid, low, mid, high, okay? And so now what you're doing is you're looking at the cosine. So that's why I'm at 1, cosine is 0, cosine is a negative 1, cosine is 0, and cosine is 1, okay? Now, if I'm going to do tangent, that's when you start getting into asymptotes. So with tangent, if you just did these key points, sine divided by cosine, because remember tangent is sine divided by cosine, well, 0 divided by 1, I would be at 0, okay? Here's pi over 2, this would be pi, okay, and then so forth. All right, so here 1 divided by 0 would be undefined, okay? So at pi over 2, you'd be undefined. Then you'd come over here, 0 divided by negative 1, great, we're back at 0. Here, negative 1 divided by 0, so at 2 pi, where am I at? This is pi, this is what? 3 pi over 2. I have another asymptote, I'm undefined. And then I come back here, I'm at 0. Well, that doesn't really, kind of tell you what the graph looks like. I know I'm going to have an asymptote. This guy is going to be 0. I mean, I can tell the pattern, but that's not really what it looks like. So what we do is I need to add more key points. So we add in these 45s, which are pi over 4. So I'm just going to cut everything in half here because half of a half is a fourth. All right, and then here you have square root of 2 over 2, square root of 2 over 2. So when I divide that, I get 1. So now I'm like, oh, okay, this guy's going to go at 1. Right, and then this guy is at what? Negative 1, right? And I get these curvy little deals, okay? So then this guy is down at negative 1, this one's at a positive 1, and I keep going, and same thing here, negative 1, positive 1. I do better when I do the curvy first. And there will be an asymptote over here, and then same thing over here. I'm going to kind of try to get that part first. Okay, and then again, another asymptote. So tangent, looks a little different. Now, these are the key ones, okay? Remember, if I do cosecant, it comes off the hump. So this would be like an asymptote for it, and it would come off the humps and the humps. And so, as this keeps going, it's going to come off the humps. Same thing here. It's going to come off the humps. And your asymptotes are going to be every mid. So every mid is going to be an asymptote, okay? And then same thing here. If you have cosine, I'll draw it down here. Cosine looks like a cap. So starting like that. And again, obviously it goes forever. All right, but then secant would come off the humps there. And so you don't really get the middle graph. This is going to be like an asymptote in a weird way, kind of, guiding you on how to graph, but it's not really part of the graph. It's just kind of a guide. Oh, I lost my cap. Oh, well. And so this would, go off to infinity, go off to infinity. And again, asymptotes are going to be everywhere it crosses your mid, okay, if there's a transformation, okay? And then cotangent, is going to, flip over this way, right? And then also it's going to be shifted. So again, if you wanted to do cotangent, you can see like 0 divided by 1 is 0. Well, yeah, but now the undefined is going to be here. So this is going to be undefined, undefined, right? These are going to be 0 and 0. Okay, these answers are going to be the same, right? Because if you flip a positive 1, you get a positive 1. If you reciprocate a negative 1, you get a negative 1. But it's going to look like this, but again, it's not going to go through that, right? Things are going to get shifted. All right, that's kind of just the general overview. All right, let's do a graph. And let's do y equals, say, 3 sine. We'll do 6x minus pi plus 2. Okay. I like to deal with the output first. Okay. So the normal output is a sine is trapped because remember it looks like an S is the first 5 key points usually. Okay. And that's between 0 and 2 pi. And that's when it does it. Now, again, we know this goes forever, right? I'm not saying it doesn't. I'm just focusing on those 5 key points. So I'm just focusing on this. Okay. All right, so usually that happens between 0 and 2 pi. All right, and the range goes from -1 to 1. All right, but we have amplitude here. Let's put a negative on this. So if it's negative, that's going to reflect this. So it's going to go like that. It's going to be a reflected S. Okay, it's going to look like that. Now, the absolute value of that is 3. So I'm going to multiply it, not by a -3. I'm going to multiply it by 3 because I still want this go from low to high because that's how interval notation works, right? Left to right, low to high. So the amplitude of this, I'm multiplying by 3, amplitude of this, multiplying by 3. All right, but now I have the vertical shift. So plus 2, plus 2. So what is it? -1 and 5. All right, so already this is dealing with output. This is dealing with the ratio part of the graph. I know that it is going to go from a -1, that's going to be my low, and then 1, 2, 3, 4, 5, positive 5 is my high. And my mid is going to be my shift. So my mid, I'll just put a little dash line there. Okay, this is my mid at a positive 2. And again, halfway between, right? A distance of 3, distance of 3, but it's also your vertical shift. All right, that's my mid. Now let's deal with the angles. Okay, so normally we see this behavior, okay, between 0 and 2 pi, but we have a transformation on our angles. So we're going to go ahead and trap that transformation between 0 and 2 pi. Because normally we would start our S and end our S, but we have a transformation. All right, so I'm going to add pi to everything. So add pi to the left, the middle, and the right. Right? And then I'm going to divide by the 6. So I get pi over 6 x. And usually we'd reduce this to pi over 2, but I don't really want to because we're dealing with units. Now, from pi over 6 to 2 pi over 6, 3 pi over 6, that is not a lot of tick marks to, draw your graph. If I put it over here, you can kind of see it. If I go pi over 6, 2 pi over 6, 3 pi over 6, that's not a lot of tick marks. So I am going to cut these in half. So I'm going to go ahead and get a common denominator. I'm going to multiply by 2 to get, what is it? 2 pi over 12. And I'm not doing anything to my x. I'm just changing my denominators on these. All right. And then I'm going to multiply by 2 and get what? 6 pi over 12. Okay. So I'm going to use that common denominator to get more tick marks. Okay. All right, so I'm going to use pi over 12. This will be 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12. And I don't really care if you reduce because these are to help you graph accurately, not other people. So they're just to help you. Okay, so let's look at our graph. All right, so we're using these. This is your start. This is your end, okay? And we have to think about what we're doing. We're doing a reflected S. So we're going to start and end at mid. So at 2 pi over 12, which is right there, 2 pi over 12, we are at a mid. At 6 pi over 12, So let's see, that's this guy, 6 pi over 12. We are at a mid. In the middle of them, we have a mid. So if I go in, 1, 2, I have another mid. I think I'm going to sneeze. Excuse me. Okay. Now, what happens between these two? I have a low. So between these two mids, on this tick mark, I am going to have a low. And between these two, I'm going to have a high, and that's because it's reflected. All right. So I have my 5 key points there, and trying to make these not too pointy. So because every tick mark is a change, I'm going to go up here and go there, and then here it's going to be a mid. Next tick mark is going to low. Now, if you have tons of tick marks, you might have to change, go 2 tick marks before you have a change. All right, so then we got that. This guy is going to be what? Back up to a mid. Okay, and then same thing over here. This next tick mark is going to be a low. And then the next one's a mid, and it's going to keep going. Okay, all right, as far as some key elements of this thing, you could graph it, but you really don't have to see some of these things. The amplitude is the distance from the mid to the high, and its absolute value, so that would be 3. That's this guy. Vertical shift is up 2, right? It's going up 2. Your phase shift, if you solve this guy, is that pi over 6, plus pi over 6, or you could say positive 2 pi over 12, but it's to the right pi over 6. So phase shift is plus pi over 6, or to the right pi over 6. Your period is 2 pi divided by the coefficient of x. So that's pi over 3 is my period. Let's see, domain is all reals, right? This thing goes forever and ever. Your range is normally -1 to 1, but again, we have stuff done to that. So -1 to 5. Did I hit most of them? All right, I think I did. Okay. All right, so it's not as bad as you think. All right, let me pause and we'll write another one and we'll go on that one. All right, let's look at this one. I went ahead and did the range. So -1 to 1 multiplied by 2, did the phase shift. All right, let's look at the angle. Okay, normally the angle is trapped between 0 and 2 pi, because and this is a cosine. So this would normally look like a cup for those first 5 key points, okay? All right, so we have some stuff going on the angle. Subtract the pi over 2 from all of them. So minus pi over 2, minus pi over 2, minus pi over 2. All right, I need a common denominator, so I'm going to put a 1 there, and this is subtraction. So times 2 times 2. So I get 4 pi over 2 minus pi over 2. So that's going to be 3 pi over 2. To get rid of dividing by 4, I'm going to multiply by 4, multiply by 4, multiply by 4. So that gives me a -2 pi, and x, and 2 goes in there, 6 pi. All right, it looks like I have plenty of tick marks, okay? All right, so if I go from -3, so 1, 2, -3 to 1, and where's my mid at a -1? So here's my mid at a -1. All right, I'm going to start at -2 pi and end. So I have a lot of tick marks here. So what? I have -2 pi. So I don't think I need to cut more, because if you look, I have a lot of tick marks. All right, I edited a little bit, but here's your phase shift, -2 pi. Now notice that is your start at a high. I went all the way to the end. See how I have so many tick marks to get here? Halfway in the middle, I went and found my low. And then halfway between these, I found my mid. So notice I'm skipping 2 tick marks because I have so many tick marks. So if I keep going, I'm going to have to go 2 tick marks before I get to the next thing, like a mid again. Or over here, I need 2 tick marks before I go to the next thing. All right. So again, if you have tons of tick marks, you don't need to cut it in half again. All right. So again, amplitude is 2. Domain is all reals, goes forever. Range is from -3 to 1. Phase shift is left 2 pi. Vertical shift period is 2 pi divided by the coefficient multiplied by the reciprocal, 8 pi.